Topic 9-1, the areas of and perimeters of rectangles. These can be referenced in our Holt textbook in several locations. First one is in the first chapter, section 5, page 36, and also chapter 9, section 4, page 616 through 621. Alright, knowing the difference between, first we'll look at area. Area is the number of square units in the interior of an object. So if you were given a grid like the first one and asked to find the area, you could just go and count all of the squares that you see inside this shape. You'd find that to be 98. It's actually 7 squares this way and 14 squares that direction. 7 times 14 is 98 units squared. Also, you may be asked to look at what's called an irregular shape. In this figure, if we were going to approximate the area, you can notice that this was curved lines and these are shaded in, and you can count the number of partial squares by just kind of thinking, well, that would be 1, maybe that's 2, 3, 4, 5, that little part with that is 6, and this might make up about a half a square more. So it's just an approximation of about 6.5 of the shaded ones, and then all the ones that were not shaded, you can just start adding them up. This just totals up the rows. So 60 and 6.5 is 66.5 units squared. So that's just an irregular shape that you can take partial units and break up what's called composite figures on the inside and add them all up. So a rectangle is a parallelogram with 4 right angles, and to find the area of a rectangle you multiply the measure of its length by the measure of its width. So the area of a rectangle is length times width. A lot of times just using these letters. Okay, let's do some other examples making use of our radical, remembering multiplication of radicals. If you were to find the missing number on number 3, and first they want the length, so that'd be 5 square roots of 2 units. Units placed when there's not any kind of feet or inches labeled. Width is 4 square roots of 2 units. When you multiply, make sure you remember you multiply the whole numbers and the radicals. 5 times 4 is 20. Square root of 2 times square root of 2 is square root of 4. So remember that the square root of 4 is just 2. So you're just multiplying 20 times 2. Okay, here's one that they've given you a 30-degree angle here. Well, if this is 30, then we know this one's 60. A 30, 60, 90 has values of x square root of 3, an x, and a 2x. Remembering our 30, 60, 90. If you do forget that, you can always refer to it on the geometry reference chart, and it's shown to you at the bottom of the second page. So you can take a look at right up here the values of the side lengths. So if it was given to you that the only thing given in this case was the diagonal, which is 4. Well, if you remember that it takes 2 of these to make up that, then my short leg is going to be a 2, and the long leg, you just are replacing that x in what your value is, so it would be 2 square roots of 3. Therefore, you're going to use the area being length times width. You've got 2 square roots of 3 times 2. 2 times 2 is 4, and the square root of 3 you keep in radical form, just square root of 3. A square is a parallelogram that is both a rhombus and a rectangle. To find the area of a square, you multiply the measure of the lengths by the measure of the width. So again, it's length times width, but in a square those length and width happen to be the same, so a lot of times you will see area of a square as A equals S squared, sides squared. Alright, so an example that shows this square It doesn't mention that it's a square, but it does show by tick marks that they're all equal. By knowing that, you know that this side is the same as this, same as this, same as this. So if you want to actually put them on every single side, it'll help you with not only area, but also perimeter. Alright, but this one they're just asking for area. So area, you're just going to multiply the one side by the other side. This one ends up being a quadratic because you're going to take 2 of your x minus 2, x minus 2. So you remember to do your mental, some people call it FOIL. I like to use the word distribution. X times x is x squared. X times a negative 2 is negative 2x. Multiply the inside. You get another negative 2x. And the last ones, you get a positive 4. So first, outer, inner, and then last. If it helps drawing arrows, do so. But that's the first thing. This would be the second one that you multiply. That's the third, and that's the fourth. You've got to remember to combine like terms. So that's how we get the negative 4x. So your answer to this area is a quadratic. And your length and width happen to be the same. Okay. This next one is using the diagonal of a square, which in previous lessons we've learned to use, and it's on the star chart. I'll try to show it here at the very bottom. It shows the values of the side lengths, the 45, 45, 90. This side is an x, this side is an x. This value of this diagonal is x square root of 2. So if you were given that the diagonal is a 6, you would say 6 is equal to x square root of 2, multiply by a product of 1 to rationalize the denominator. You're wanting the square root of 2 to go away. So if I multiply by a square root of 2, again I get square root of 4, which is just 2. And then 6 times square root of 2 you would have to keep. You don't combine that and call it square root of 12. You have to keep it separate because there's your whole number and your radical. And of course the 2 square roots of 2 goes away when you multiply on both sides by a product of 1. This does, however, reduce to 3 because 6 divided by 2 is 3. So your x value is 3 square roots of, that looks like a 3, it's supposed to be a 2. 3 square roots of 2. So because this is a square, both my length and width would be 3 square roots of 2. And my area is multiplying 2 of those together. And be careful here because when you square, you're squaring the 3 and the square root of 2. That's where the 9 times 2 comes in so that your area is only 18. Again, see me if you want to go over that in a little bit more detail. The perimeter is the distance around an object. You can look at perimeter being equal to 2 of your lengths plus 2 of your widths. Because all 4 sides of a square are congruent, you can find the perimeter by just saying that 4 of your s's, 4 of your sides on a square. Okay, the first one, however, is a rectangle. So let's look at that one. The length of a rectangle is 4 more than twice its width. Another way of putting that, which they don't show it only in expressions, but I went ahead and drew a picture of this example, and that would look like this. If you say 4 more meaning plus, then twice, that means 2 of my widths. So 4 more than twice the width could be represented like this. So if I'm trying to find the perimeter and it equals 62, you can look at 62 being the complete thing and walking around how many of my W's. I have 2 here, 2 more is 4, 5, 6. That makes up 6 W's plus 4 and 4 is 8. So all of what they got down, 6W plus 8. It's shown a different way here. You can walk through that on your own if you'd like, but I think drawing a picture and adding up however many W's are represented and then how many constants, you can get to it a little bit quicker, because you're going to subtract 8 on both sides and divide by 6, and you'll end up with 9, because 56 equals 6W and W is 9. So your width is 9. Well, if your width is 9, if W equals 9, you've got to substitute it in right there. So 2 times 9 plus 4 is where they got 22. How did they get that? They got, oh, sorry, right here. 2 times 9 plus 4 is 22. So if this is 9, the width is 9, and this is 22, multiplying 9 times 22 will give you the area, 198. Again, the best way to do one like this is to draw a picture. Make sure you draw a picture. Alright, let's look at, I think I'll cover up as we go. Let's do a little at a time. This one, number 8, actually think of PT, Pythagorean theorem. They've given you the diagonal and they've given you one of the sides. So this can be using Pythagorean theorem, which if you'll think about it, you can make sure that you always use your hypotenuse as your C. So 8 squared is equal to the 6 squared plus the B squared. 36 subtract from 64 is going to give you your B squared by itself. Well, 36 subtract from 64 is 28. If we're going to leave this in radical form, sorry, that doesn't look very good, 28 factors to, do your factor tree under the radicals, 7 times 4. 4 factors to a pair of 2's. We know that the square root of 4 is 2. So this is factored to the outside of the radical, but that 7 has to stay underneath the radical. A little tricky, review with your teacher if you need to. But your B is 2 square roots of 7. Your length was already given to you as 6 units. If you were trying to find the perimeter, you want to fill in your length and your width and multiply. You can't add these together because of this radical, and this is a constant. So your perimeter stays 12 plus 4 square roots of 7. Okay, look at the next one. If they gave you a length of 2 square roots of 3, we know this is a square, so we're looking at a 45, 45, 90. This length value is an x, this length is an x, and this is equal to x square root of 2. So this is a little bit messy. Let's walk through that again. I'm going to do it with you. If you say 2 square roots of 3 is equal to x square root of 2, you want to solve for x, you're going to divide this whole thing by square root of 2. Square root of 2. Yes, it goes away here, but I need to rationalize the denominator over here. So I want to multiply by just a power of 1. Anything times 1 is itself, but getting that radical out of the denominator is what we're looking to do here. This is actually just going to be a 2, and this is 2 square roots of 6. The only thing that's multiplied are the things that are under the radical. This would stay here. Square root of 2 times square root of 2 is square root of 4, and therefore square root of 4 is 2. Guess what though? This cancels out so that you do get that length as being just square root of 6. So that's where they got the x being square root of 6. So for perimeter, you've got 4 square roots of 6. They're not asking for area on that one. Okay, number 10 is a composite figure. With composite figures, you want to break them up into smaller parts. You can imagine a line being right here. Might be hard to see. It's shaded as dark as this is. And then a line from here to here. Well, if this distance is 5, this distance is 5. If this distance is 6, this distance is 6. Likewise, this distance is 5 and this distance is 5. So making it up into three rectangles. So you've got 3 rectangles. It looks like for area, the area they did something different. They used this whole thing. This whole square, if this is 5, 6, and 5 is 16. So 16 times 4 is going to give you this entire rectangle right here. 16 times 4 gives you the area of 64. 6 times 6 gives you the area of this smaller square here. And that's 36. This is 6. So 36 plus 64 is what you would do to get the total area of 100. And this is 100 units squared. For perimeter, it's not squared units. You're just talking about walking around it. So you're just starting to add up. 6, 6, 5, 5, 4, 16, 4, 5. So they just added all those up to get 52. Lots of examples for topic 9-1.